I love music, and sometimes when I listen, I close my eyes so I can visualize it in front of me. Now this sounds silly, but can we actually hear what things look like? When an instrument plays a note, sound travels through vibrations in air molecules, like a wave. The frequency of this wave, or how many cycles pass in a second, determines the pitch of the note. Different pitches have different frequencies. So what about when two instruments play the same note? The frequencies of the waves are the same, but there's obviously a difference. So what distinguishes them? It turns out instruments don't produce the simple waves shown earlier. What they produce can actually be represented as a bunch of these simple waves with discrete frequencies called pure tones put together. So although the frequencies of the waves are the same, the waveforms, shown as the unique combination of pure tones, are different, leading each instrument to have its own distinct sound. So back to our earlier question, do sound waves carry information about what an instrument looks like? Well, in a sense, yes. If you isolate the frequency of the lowest pure tone, known as the fundamental frequency, it tells you about the shape of the instrument. In one dimension, like a string, it's equal to 1/2 the length of the string. In 2 dimensions, like a drum head, it's not as simple, but it relates to the perimeter and area of the drum. We can solve for this by solving for the eigenvalues and eigenfunctions of the Laplacian derived from the wave equation, which can get really complicated. Luckily for us, our ears are surprisingly good at it. When they hear a pitch, they subconsciously decode the fundamental frequency and provide its corresponding information to our brain. So although we can't hear the exact dimensions, in a general sense, we can hear the shape of an instrument.